Okay. What for you to open?
Left one. You have two of them open. Remember?
Oh. Why?
There you go.
Can I close this one?
Yeah.
All right, cool. Let's go to here. This is technically 6-5?
Yeah.
Well, 6-5 part A. Okay. So here's our purpose today. We're going to talk about the complex numbers in polar form. We probably won't get to De Moivre's theorem. But I want to kind of start it off, get some stuff out, get you guys a little bit of homework, probably about 5 to 10. Again, my bad. We're not going to get through the whole thing, so don't go crazy about it. We'll get to probably right about here somewhere. It's all going to be the complex numbers, okay? Now, top ones. Probably the first three, maybe the fourth. We'll see how we are. Definitely the first three, maybe not the fourth one. We're going to go as far as we can until I feel like you guys are like,
It'll be like the first one. First slide, I'm already going to be. Like we know from the tennis course, can't do it, brother.
Okay, so let's talk about some stuff then here. Language, use specific content. Let's talk about some of the vocab you need to know. One, the word is complex number. Oh, you go away. So, first word, complex number. A complex number is composed of two parts. It's got a real part, it's got an imaginary part. Usually it's written in the form of A plus BI. This is a complex number. Okay? So A is the real part. Obviously the part that has I will be the imaginary part. So together they make a complex number. The first part is real. The second part is the imaginary. Okay? Know the difference between the three. Sometimes I say, hey, here's 5. Write it as a complex number. Don't just leave it as 5. That should be 5 plus 0 i's. Exactly.
0 I.
Yes, sir.
Because you don't have any of it.
Because it has to be complex. Remember, there's a real number, there's imaginary numbers, and there are complex numbers. And complex numbers have both parts.
What? You just popped in and out like, oh,
Welcome. That's okay. The more the merrier. The more the merrier. Questions on complex number?
No, but don't.
Question on real number?
No, don't change it.
Question on imaginary number?
No, don't change it.
All right, cool. We are graphing these today. And this is so difficult. This is so difficult.
Whenever you say it like that, that's never.
Okay.
That's never different.
What's up?
Never.
I know it's boring.
Raining.
Don't sneeze.
Watch out for the hydrogen monoxide! Be careful, the floor's wet too.
No running in the hall.
That gets cold and he's like this. Like that helps.
Oh my gosh, better not.
Do you guys feel better when you cross your arms?
Yeah.
What?
You're warming up your body because you're.
What are you talking about? You don't even know what I'm talking about when I say weather.
What did he say? Because of the hydrogen monoxide.
Watch out! The hydrogen monoxide is falling from the sky.
That's a lot of water.
All right. Thank you.
A lot of that.
Let's graph some of these. But before we can graph them, I got to show you where they go on. Okay? So you already have the Cartesian coordinate system, which we graph x, y's on, correct?
Yeah.
We have the polar, which is circular in nature. And now you need the complex plane.
Fun.
The complex plane is composed of a real axis
And an imaginary.
that is left to right, kind of like our x. And then we're going to have an imaginary axis that goes up and down, just like y. Welcome to the complex plane. That's what it looks like.
What's on the imaginary is the y.
So up and down is imaginary. Left to right is complex, imaginary. I hope I spelled that right. And that looks like Ralph. Well, it is supposed to be real. So your real plane goes left to right. Your imaginary lane goes up and down.
Real is x-axis, y
It's imaginary.
is imaginary.
If you want to make that connection, that's cool. Okay?
I think it makes it easier.
It's pouring out there.
And together they make what's called the complex plane. You good? Now let me show you how hard this is. 3 plus 4i,
Oh wait.
I'm going to graph like this. 1, 2, 3 on the real. 1, 2, 3, 4 on the imaginary.
Oh, we've done this before. We did this in algebra 2.
It's close enough. Did you blink?
How'd you
Wait.
get X?
Wait, what's the
There is no x.
4?
Oh.
Wait, so you go up 14?
That was so funny.
What?
Don't play with me. Questions?
No, we've done this before in algebra 2.
Yeah, you should have done this already. So are we good with this part? Do we need to do any more?
No.
Okay.
What's the title of this lesson? Oh my god.
Math.
Don't do it.
Complex numbers in polar form. If that's what you want to call it.
Is that it? Like for that part? Like the beginning
No.
part?
Really hard, isn't it?
They want us to plot this.
But
We want to plot 2 plus 3i. So, 1, 2, 1, 2, 3. There they are. There is 2 plus 3i.
Oh my god, it's so complicated.
Okay?
Why were you scaring me like a little bit? I was like,
It almost feels like pre-algebra again, doesn't it?
Yeah.
How do you graph that?
negative.
Oh my god, they're negatives! What?
Oh, so you go down.
Go backwards. 1, 2, 3. 1, 2, 3, 4, 5. Line them
Are you
up.
serious?
There you are.
Are you gonna add more stuff and it's gonna be cost?
Yeah. Because we're graphing on a complex plane. This is very complex. How about that?
It's just a negative 4 0.
I'll put 4.
Yeah.
Greg, how am I graphing this?
Oh,
His face. So you use that
Complex plane?
real?
No, what's it called?
The complex plane?
Ah, you shouldn't have said it. And?
It's a Z? Shit. Oh no, I'm not into the Z's.
don't even worry about the
Z is equal to the complex number, bro. Z is equal to the complex number.
Wait, hold up. I get that example down.
1,
Back.
2, 3.
4.
So it's
4.
just right on the. Huh?
Oh, look, you are a genius.
Okay. Sounds good?
So it's just the same shit?
Whoa, whoa, whoa,
Or
whoa, whoa.
Same thing?
Yes, very similar.
Same shit. Sounds like me.
How about that?
It's just gonna be 1 on the negative 1 side.
Thanksgiving? Who said Thanksgiving? Or am I hearing things?
You're hearing me.
I can't hear you guys well. There's like so much ruckus.
It's just the real.
No, I want everyone to be quiet so that we don't have to scream. And people can even hear me in my normal tone of voice. It's not happening. It's not happening.
You go up.
Oh my freaking lord.
Jesus. That's your normal tone.
I'm doing that all the time now.
No, you're not.
Questions here? Okay. Are we good? All right. Thank you. I think you guys get the point on graphing these. Now, before I go on to the next part, I give you some crazy formula that you're going to go, oh my God, probably. Let me ask you this question. Because we need to find the absolute value of a complex number. Okay? We need to find the absolute value of a complex number. Now, let me ask this question. Please don't give me an elementary definition. Give me a grown-up high school definition, high school, college level mathematics. When we talk about absolute value, what are we talking about? Distance from zero. Absolutely, thank you. It's always plus. So we're talking about the distance from zero, okay? So let me give you a visual. Let's say I did plot some real number. I'll put up another slide here. So I grabbed, sorry, not some real number, some complex number over here. We'll call it, I don't know. What is this? Be quiet. So we have 3 plus 4i. So technically that's this, right? 3 plus 4i. When I'm looking at the distance, I'm looking at the distance it has from 0. Does that make sense? So it's still that same definition. How would we find that distance? Any ideas on how we find it? What?
Triangle.
The Pythagorean theorem?
I thought it was slope. Can you find the slope of the
Well, you know what? And yeah, technically you're correct. That's what I would say. But what's the formal thing that we use? The distance formula, correct? So, if you want to find the absolute value, you're really just finding, using the distance formula, you're using a squared plus b squared, then you take the square root of that. Because again, we're just finding the distance that our complex number has from 0. Does that make sense?
Yes.
Quick question.
Okay, go ahead.
So let's say like A was negative or B was negative, and you have it in the absolute values. Well, whenever you put it into the square root, is it? Oh, it doesn't matter no matter what.
You've answered your own question, correct. Remember, absolute value is simply a distance. Distance from 0, and that's what we're after. Okay?
Can't go change this now.
So basically, you're just, instead of doing a squared plus b squared and c squared, you're already just putting square root over.
Well, we already have a and b, right? We're just finding c squared, which is technically the distance.
What? Wait a second, hold on. Wait a second, what happened here?
Are we good? I can change this?
What is Z?
Z represents the complex number. Okay?
Oh.
That's all it represents. I shall be here Friday.
After school?
No, not after school. She just won't be here Friday. I will be here.
You get DOS pay if you don't come on the last day of break.
Why would I?
My mom does.
Oh, I know there's blackout dates. I know what you're talking about. I don't know if we have blackout dates. I don't know.
Have you brought anything to take I'm sorry, I was going to party. Thank you.
Well, you know what? If I'm sick, legit, and it's that day, I'm sick.
It was like
There shouldn't be blackout dates. Now, if you found out that I wasn't, then yeah, you should go back.
Not like the Bahamas party. Or like,
Bahamas party. I've never been to the Bahamas. I can change this? Okay. Let's do something just simpler. Let's do that one for now, okay? Because I think you get the idea. Find me the distance here, please.
Find the distance?
Yeah, find me the, find me the absolute value.
I'm out.
Okay, so
Look at you, mental mathing over there. Beautiful.
When the I square rooted is just one.
Not I. You don't worry about it. It's just A and B. So it's just the 2 and the 3. Don't even worry about the I.
do you want it like,
So it's 13 squared.
do you want, I get it, it's square root. Isn't it 5y?
And then you put an I after it.
because it's just the distance.
No.
Remember, I is simply giving me a coordinate on that imaginary axis.
What's the answer? Because subtract the value of A and B.
Because you get that negative out of it.
Yeah, and then the negative is I. You're gonna get this thing. You're gonna get negative. Let's go. I was right.
Okay? So the absolute value there, or the distance it has from 0, is the square root of 13. So what, 3 something?
Yeah.
3 and some change? Okay?
Wait, no.
Okay.
Wait, did we turn this in?
These are notes.
No, he's just talking about.
That fixed 6.4 thing.
No, 6-4 is not due today.
Oh, well,
It's already done.
I did it.
Till tomorrow maybe.
I'll figure out how to work for it.
Okay? Alright. Is everyone done copying? What? You good with this? What are you working on?
Mr. Munoz, do you have any cough drops?
If I did, I couldn't give them to you.
Oh,
I'm not
yeah.
allowed to. Alright,
Well,
Now-
technically,
I'm gonna move on. We're good?
Yes, just leave it so.
I understand that we're graphing now on the complex plane, correct? But it's still rectangular in nature, correct?
Correct.
Up, down, left, right?
Yeah.
Okay, so when I give you something in a plus bi, it is in rectangular form. You will have to change it from rectangular form into
Polar.
polar
That's
form.
the worst thing.
Here's the way you do it.
This is where it gets.
Here's the way you do it. You take a plus bi and you're going to put them in the form of z equals, because remember, a is cosine, right? It's kind of like the left to right side stuff.
Yeah.
And b is the sine value, correct? So what we're doing is we're going to put the radius up front, which happens to be technically, come on, distance.
Yes.
Right? And then we'll have the cosine of value, and then we'll have the sine value I.
So would it be cosine of A?
Correct. No, cosine of theta, of the angle that's created. And we can find those things because we know trig. Once I know the distance, correct?
Yeah.
Then I should be able to find all the other stuff.
And you know the height, yeah.
Because the distance gives me, it should be in that rectangular form, I should have AB, so I
Yeah.
can find that angle that's included.
So you would
That makes sense? So now we're just putting all our trig back in and recycling some of it.
Okay.
see it.
It shouldn't
Because
be
now
too
we
bad.
have tools in the tool belt.
So the,
Okay.
I think it's a tool shed.
I was gonna say shed, but it's not the shed, in our belts, in our tool belts.
Technically, our tool should
Okay.
be our brain.
So please write this down. You need this in order to convert back and forth. Okay. Here's the actual breakdown for you guys. Can you guys read that okay?
Yeah.
Because we do have some more vocab in here. So this is the polar form of the complex number, where a is r cosine theta and b is r sine theta. Do those look familiar to you?
Yes.
Yeah. Except with our formula, because they both have r, we can factor it out.
Yep.
Does that make sense?
Yeah.
So that's what you're looking at.
Yeah.
Good to know. R is called the modulus. R is called the modulus.
Or modular.
Plural form is
Modular.
moduli of the complex number z, and the angle theta is called the argument. Okay, so we have the modulus, and then we have the arguments, and those should be in the 0 to 2 pi range. What happened? Someone dropped your croissant? Or did you say l'amassant? I dropped like my l'amassant. Darn those l'amassant. You guys ready to try that?
No, hold on.
No! You ready to try that? Yes. That marker's been jumping on my hand all day.
You dropped.
Got butter beaters.
What? like over there I was writing and twice. Oh,
We only did that in
Mr. Miller sends you guys a challenge.
No.
That's it?
It's right over there in the green triangle.
Nah, I'm solid.
Solve it. You know what? That might be the next one I give you guys because
No.
you know what's due tomorrow.
There's something new.
There was
Yeah.
no
Oh shit.
What time question?
There was
Your
an
square root
No, you
question.
said
I thought
Friday.
it was due Friday.
Were you not here for that?
I
You said
thought
Friday.
it was
I wasn't here, probably.
I said Friday.
You said
You
Friday.
said next
I
You
don't
said I'll give it to you this Friday. And they're like,
What
you
should we look
know
I
what?
swear
I'll give
you
you guys
said
an
May.
extra week, like till Friday.
That was
Friday.
2 weeks ago.
No.
No,
I don't.
Yes, it was.
I swear to God.
Wait, I don't even know what
I
question
don't
you're talking
dare
about.
stop.
Our problem.
Which one is small? It's due tomorrow. Yeah, don't. I gave it to you on a Wednesday. I said you have 1 week. And I said, you know what? I'll give you 2. One to solve it and one to.
I don't know why you just
I don't
like
have
you
it.
gave it on a Friday.
You don't have it?
No, I don't have the problem. Wait, what's the problem?
It's this one.
It's this, give it to me real quick.
10 plus.
Yeah, what is it?
Which one's bigger?
Problem is-
What is it? Square root of?
Oh,
Yeah.
So it's the 10th root of 10?
I thought you said Friday.
But you can't use the calculator.
What was the other one? The 3rd root of 2? That? So the question is, which of the 2 is bigger?
oh,
I know.
And you can't use a calculator. That's like,
oh.
I'm not even trying.
Why can't you?
That's for tomorrow.
Right? Wait.
Because I don't remember getting
Nice. I was in the bathroom watching you.
No, I just had it playing.
Oh.
What the?
What would be funny, she was over in the bathroom. What problem?
No, I finished that. I was about to.
So which one's bigger was your work problem there?
That's due tomorrow?
That was due tomorrow.
You have to share our work?
Oh.
No. I gave it to you on a Wednesday.
Here,
I
wait,
said, here's your
wait. I
problem.
think it was that day that everyone was on. Have the date written on there for it.
Put up what?
You had the date written on for what it when it's due.
Did I even save it?
Oh yeah, you said March 15th. You know what? I even wrote it down, Mr. Lee.
March 15th.
Which is Friday. Oh, March 13th.
Thank you. She wrote it down. March
Didn't you write
15th.
it?
Thanks for having my back.
Yeah, you should have said March 15th after that.
Oh.
I wrote down March 15th.
2 weeks ago, I gave it 2 weeks ago.
All right.
You had 1 week to mess with it.
Right by
and 1 week to type it. But you were not
Yes,
in
it's
your
a 5, I swear.
full capacity.
No,
So you probably wouldn't
Trevor, I
even
write my 5.
You probably wouldn't even hear that one. You don't stop stressing right now. Stop. Leave it alone. Don't even do it.
What?
No, not you. Her.
Me too?
No, not you. Her.
And how much which is
That
bigger?
is really
No,
Fernandez.
just don't do it. I don't want you to stress over it. Okay, then do it. I'll give you till come back from spring break.
Yeah, we have, can we not use that we're all stressing over it?
No, she was sick. Legitly sick. She's gone for like a week.
My name's suddenly Fernandez.
I'm suddenly saying,
I am suddenly like, that's some bold, right?
All right, take a stab at it. Here is your polar. Sorry, your rectangular form. Put it in a polar, please. Polar pop.
Did you guys know you could get a free stack of pancakes from IHOP?
Today.
You're welcome.
Thank you.
today?
Oh my God.
No, you can't. You tell people because then you can't really get anything because everybody knows it's like, yeah, you're not gonna get nothing.
That's why you leave school early to go get it.
Some of us can't do that.
Guys, I gotta go. I'm not feeling so well.
How
I'm
big is
sick,
the stack?
gotta go.
It's
I am leaving.
two. They give you 2 because technically 2 is a stack.
Free syrup?
Wait, how the hell would you do that? What?
As much syrup as you want.
Syrup's on the table. Just take the syrup.
She's gonna go home and just steal the pancakes. Just let them drip.
So we have.
All my syrup.
I don't know. What's the question?
That's hand sanitizer.
That's it, right?
Negative square root.
We have 2 minutes.
What?
Would it be the
Just
negative?
Oh.
When you can
Would it be the negative square root of 3?
I was like, man, I'm over here. I'm just playing around.
Because I and, oh no, no, would make it positive. Because no, I is already
What?
negative.
Alright, something about a green.
And then it should be positive, right?
That's Mr. Miller's challenge to you.
Disgusting.
That, I say that might even be
That
your
is nasty.
your next problem.
No, I don't do I reject.
Don't move so fast, there, Raza.
Oh. I'm like, I'm waiting. I'm like,
Right.
it's too, right?
Alright, what's the graph?
It's for the distance.
It's a 2.
And so,
Oh no.
Wait, what?
No, that's the square root of 3.
Square root of 3. What?
Ah. You child.
Why is it negative? When did it become 3?
Oh, that was not supposed to.
Why is it the negative part?
It's negative.
Yeah, oh, okay. Okay, never mind. Oh, okay. Yeah, same fucking thing. You still got the same result. Doesn't matter. Man. If we have A and B.
Is it plus sign?
A and B. Yeah. Since we have A and B, now we can make our triangle, right? Like find out what the angle is.
Wait, it's too early.
What?
So now we have A and B plus our R. We just figured out our angle, right?
Yeah. Everyone okay with how I got my radius? I just used the distance formula like I said. Are you recording me? You go, girl. Here we go. Next part. Now I need to get the angle here. Here's what I know. Here's what I know. I know that I've got a -1, correct?
Yeah.
And I've got a negative radical 3,
Yeah.
correct? So -1, negative radical 3. I need to figure out what alpha prime is here.
Okay, do the triangle.
Well, technically I need to figure out alpha, but I'm going to use alpha prime to get me there, correct? Oh, we're looking over here. We good?
Okay,
No?
wait. Okay, I get it.
Go ahead.
I get it.
You
So-
get it?
Yeah.
Get it. Okay. Which trig function can I use to help me get that angle there?
I know.
Tangent. I know. So I'm going to ask my calculator tan inverse. Technically it's what, just radical 3? Right? What is it? Is it 60?
I think so.
It's a 60? Yeah. Correct or no correct?
Correct.
Okay, cool. So,
Yeah, correct.
how many 60s can I get up top?
That would have to be a 36
2.
90, but
It is a 30, 60, 90. Good job.
Yeah.
2 goes here.
for some reason
So, I'm trying to find that angle. I've got 1, 2, 3. Well, what the? 1, 2, 3, 4. 4 pi what?
What?
4 pi thirds.
I thought you could only get 3 6.
What?
Oh, never mind.
There it is.
18.
That's it.
Because
wait,
So you just get theta, and then like.
technically, we use theta prime to get us to theta.
okay, wait, I thought cosine.
Wait, can you scroll up a bit?
Go ahead.
Hey, why'd you get 10?
Oh, this is all you need right there, isn't it? Who had their hand up?
Wait, it's 4 pi third.
Go ahead.
So cosine theta, like the theta is not equal to 8, right?
Oh, okay.
Say that one more time.
The theta isn't equal to 8.
To 8? No.
To 8. For cosine theta,
Alright. I can understand the lesson.
That's how we write it in polar. So r is simply the distance, correct?
right?
Which is what we did first here. And we got a radius of 2. Now, I need to get the angle that's created. So what I did, whoa, where'd you go? So,
Oh, yeah. Okay. Yeah, I see now. Sorry, I see now. I get it.
you're good?
I get it.
Who's not?
I confused myself.
Who's not?
Me.
You're not?
You okay.
Okay, so, you're okay with how we got the radius of 2? Okay, good. Now, let me get rid of this again real quick. Yeah. Why you not working? Now, what is A and B? What was A? -1. So I go -1 this correct direction, right? So that's -1. And then I'm going to go down. How many? Negative radical 3, correct? Okay, cool. I need to find theta prime. Because once I know theta prime, I can figure out theta, which is what I need. What angle is theta prime? I could do tan. I could do tan. I could do tan inverse negative radical 3 over -1, which is technically just
10.
tan inverse radical 3. In your calculator, punch it in if you want. It's going to tell you that that is 60 degrees. Okay? Now, I can't put it in degrees. Okay? I have to do it in radians. So here's what I'm going to do. I know that the top is going to have 3 of them. Correct? 3 of the 60s. So I have 1, 2, 3, 4. Okay? So in radians, that would be 4 pi thirds. 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 If you wanted to do it that way, yeah. But you want to get theta, not theta prime. Okay? And we just put that over here in for theta in both positions, and we should be good to go. Okay? Jen? We are tapped out. I'm going to stop right there now. I'm going to stop there.